What's poppin', dogs? Mr. Allen here with an application of arcs of circles in this video. And this problem comes from something that I actually did over at a friend's house. He needed some help trimming out that entry door that you see right there. And we needed to know the radius of the circle so that we could scribe the arc to match that curve because it wasn't just straight across. And it took a little bit of math to figure it out, but it all worked out. And believe it or not, it was Pythag that came in handy here. So let me show you guys how this all worked out. I'm going to put those dimensions on that door right now. So let's get a horizontal line going straight across that door from end to end. And this is actually a chord of the circle of the radius that we're trying to find. So if I sketch this right across, this is 74 inches, okay? And what we're going to do there is we're going to put our height as well, which we said was 9 inches. But I'm not just going to put the height. I am going to scribe this all the way down to where I believe my center ended up being. Okay, so we're going to math this all out and see where it was. But I think it was somewhere like right below the door handle, somewhere right around there. Okay. Now, keep in mind this arc is a portion of a circle. Okay, so it's not just this little guy here. If I were to continue this, it's all part of this larger circle here, and I'm trying to find the radius of that circle. So a couple things to note about properties of circles. If a radius, and this is the center of my circle is what I'm saying, it's somewhere in there. If a radius is bisecting a chord, okay, so this whole thing all the way across is 74, which makes it 37 inches and 37 inches. I want to split it in half. I want it to be symmetrical, right? And if a radius bisects a chord, then it's also perpendicular to that chord. Okay? It's a wonderful property of circles that we got to use here. Now we said the height of that was 9 inches, and I just measured that. So I took a string line across, measured 9 inches, and that was the stuff that I was working with. So this is everything that we have here to work with. Well, if I were to be so bold, if I were to connect this right here, so center of my circle to where that chord hits the edge of the arc or portion of our circle. Would that be a radius as well? Yes. So this is also a radius of my circle. Well, you know what else is a radius of my circle? This is a radius of my circle. But more importantly, and I'm going to put this in a different color here and hopefully it shows up okay. This isn't the radius, but it is the radius minus 9. Okay, so that's the radius minus 9, that 9 inches up top. So whatever my radius is, it's 9 less. Now, what do I have here, guys? I have a right triangle with side length 37, r minus 9, and r. And what I'm going to do is I'm going to draw this triangle off to the side right now so that we don't have any of the windows and doors and stuff like that, and we're going to math it up off to the side, okay? So now I got that triangle off to the side, no distractors of all the stuff that's going on in that construction site, and let's math this thing up. How do I solve for a missing side of a right triangle? I hit it with some Pythag. Now, unfortunately, I've got two, unknowns here, but they're the same unknown, right? Two of my sides have an unknown, but they're both the radius. So what I can do here is I can hit it with some Pythag, r minus 9 quantity squared plus 37 squared equals my hypotenuse, which is also r squared. And I got to do a little bit of algebra here. So I'm going to FOIL out the r minus 9, so I'm going to multiply them together like this. A lot of people accidentally just distribute their exponent of 2 in. That is incorrect. No bueno, okay? And I get r squared. So r times r is r squared. What I'm doing here is this, r times r, then r times negative 9 is negative 9r. And then I have negative 9 times r is negative 9r. And then we have negative 9 times negative 9 is 81. Then I have 37 squared. Let's pull up the calculator real quick. Let's do 37. Ooh, I got a lot of math there. 37 squared. We got 1,369 equals r squared. All right. Now I'm going to combine some like terms. So I've got r squared, that's still chilling, minus 18r, 81 and 1,369. You know what? I'm going to keep it all in the calculator. Let's just be safe. So add 81 to that. We got 1,450. So plus 1,450 equals r squared. And I got to solve this thing. And it looks intimidating because it has r squared. But if I subtract r squared on both sides, what happens to those r squareds? Boom. They are gone. And now what I'm going to do is I'm going to add 18R to both sides. Oops. Because on the right-hand side, it was just 0. And now I have 1,450 equals 18R. How do I solve for R? I'm just going to divide by 18. On both sides, of course. Divide by 18. Let me pull my calculator back up so I can see it. Divide by 18. And we get 80.5 repeating inches. I'm going to convert that to 16, so I'm going to subtract off 80. Now I'm just left with the decimal. Multiply that by 16 to get however many sixteenths that is, which is 8.8 repeating, so 9/16. So we have 80 and 9/16 inches for my radius. 80 and 9/16 inches for the radius of the circle that we could use to scribe that arc. And it actually worked. Like we set something up, a little jig. I put a screw in some wood, and then took my tape measure, and then I just went along there. I'll put a video overlay. But it actually worked and all fit together really nice, and kind of awesome that Pythagorean theorem all of a sudden gets thrown into circles here, which is kind of crazy. But right triangles are used to solve all sorts of different problems in geometry, and they come up when you least expect it. So if you're in a bind, see if there's a way you can set up a right triangle, because it may save the day, because Pythag's the man. It's the greatest theorem of all time. But anyways, I hope you guys enjoyed that, and maybe one day you'll get a chance to actually do this in the wild like I did, and hopefully it all works out. Thanks for watching, you guys, and have a wonderful day. This is very exciting. I don't know if you understand how exciting this is. I never had the opportunity to math this situation in the wild, in a trim scenario with an arched doorway. I've just described these problems to my geocon students and whatnot, so that is super exciting. And now this is going to be on the honors curriculum, guys. Look out. Now that I know the pattern fits, I can trace it out in a couple sections on a piece of oak and cut it out. There we go. Right, we got to get it sanded. Got the rough in there. Got to fix the little keystone piece right there, a little bit wider, but overall, it's laid out nicely. Greatest theorem of all time, Pythag.